Welcome all of you. Unit number 4, AC voltage controller. AC voltage controller. What is AC voltage controller? It's nothing but auto transformer. In electrical machines, AC electrical machines, you are using the auto transformer. What is the purpose of auto transformer? Fixed AC into variable AC. Fixed AC into variable AC. You want to achieve the variable AC. How do you achieve? There is a variable knob is there. You will going to vary from that one 0 to 230 voltage or 0 to 440 voltage. You will going to vary. When you will going to vary, the output voltage is a variable AC you can get. Then what is the limitation of that auto transformer? Because the auto transformer occupy on the some space, more space it will going to occupy. Then it is a weight is more. The inside is a inductive coil, okay, copper coil they are using, so weight is more, okay, and it will going to occupy on the more space it will going to occupy. Very frequently you want to do the maintenance. There is a adjusting knob. In the knob is by bottom of the knob it is a you can point is there. That point it will going to day by day it will going to the thickness is reduced. That frequently you want to replace that point. Frequently you want to replace the point. Another one is whenever you will going to vary, at the time possible to occurs on that small spark it will going to possible to occurs. So cost wise the auto transformer is more, okay. So like it is the limitation is there. Then these type of limitations, how do you going to overcome? So the auto transformer places a replaced into that power electronics device. That device making one of the converter. The converter's name is called AC voltage controller. So AC voltage controller means fixed AC into variable AC. What is a AC input? Voltage and frequency. The output of that AC is called fixed frequency. Auto transformer also output is a fixed frequency. The output is a variable voltage. Output voltage you will going to achieve. One more converter is there, that is called a cycloconverter. A cycloconverter it will going to get it on the variable frequency also. That is variable frequency will going to get. So don't make it here is confused. The AC voltage controller is output of the voltage is the only varied, not frequencies varied. So in that unit, what are the topic you will going to learn means one is a single phase AC voltage controller. That's all. Single phase, how you learn about that single phase fully control converters, rectifier. How do you learn? Similarly, it is the same method, mode 1, mode 2 of that single phase AC voltage controller. The next one, second topic is the concept of the two phase AC voltage controller. Two phase. What is the purpose of the two phase? When I needed for more output voltage, that's why I will go for the two phase AC voltage controllers or regulator. I need for the more output voltage, so I am going on the two ones. Then apart from that one, few more topic you will going to learn about in that unit. That is called first one is a single phase TRIAC controller, TRIAC. Another one is a triggering of the TRIAC using DIAC. Triggering of the TRIAC using the DIAC. Then next one is a operation, 4 modes of the operation of the TRIAC and the introduction of the DIAC. So like it is there in the unit. So what is if you have seen about the TRIAC and the DIAC, these two is come under the thyristor family. These two is come under the thyristor family. Okay, TRIAC. Where you are use the TRIAC? Fan regulator. So electronics regulator. If okay, fan electronics regulator, fan regulator. What is a regulator? Variable of that ones. So variable the speed. So if you have see that one, okay, in olden days is the fan regulator is a electric regulator. It occupies some space. Okay, it will going to produce the heat. So when you may be touched near to the fan regulator box, you will going to realize it about the heat, and the top of that plastic it is melted due to the heat. So if I have seen inside of that one, it's a wire wound resistance is used. Wire wound variable resistance. The point vary to you will going to achieve the resistance. There are variable points. The large space and a heat producing device, and then these are the things is replaced into the small compact and less power consumption, small compact and less power consumption, that is a less maintenance, that device is you have replaced with the power electronics. Okay, it's a power semiconductor device. Which device is there especially inside means that is called a TRIAC. What is TRIAC? Thyristor, SCR. Anti-parallelly to SCR is connected. Anti-parallelly to SCR is connected means, okay, you will go to two SCR is connected anti-parallel, okay, both one is a gate terminal is joined, so you will going to get it on that one is a TRIAC. Just you can recap R type of the triggering circuit. I explained in the unit number 1. R type of the triggering circuit. The gate is a triggered with the help of the resistance. Okay. In the R type of triggering circuits, AC power supply is applied into that SCRs. Okay, it will going to conducted only half of the cycle. Remaining half of the cycle is not conducted. Okay, it is a natural commutated. So due to the variables of the power supply, varies in the north phase and neutral, so naturally it is commutated. When you have used the TRIAC over there, in the negative half cycle also conduction, that's all. In the negative half cycle also it will going to conduct it. Okay. Then next one is a DIAC. What is a DIAC? DIAC is nothing but a two diode connected anti-parallelly. That's all. Two diode is connected anti-parallelly. One diode is of a flow forward direction, another diode is a flow on the negative directions. So this is about the single phase AC voltage controllers. See, look that once. So here is a AC voltage controller. So the thyristor 1, thyristor 2. So when it is a forward direction, T1 is operated. When it is about the negative half cycle, T2 is operated. Why? So phase with respect to neutral, T1 is conducted. When bottom is phase with respect to neutral, T2 is conducted. During the time T1 is a turn off. Or these two devices are replaced into the TRIAC. That's all. These two devices, thyristor T1 and T2 is replaced into the TRIAC. So you have look the diagram. It's a input AC waveform, positive magnitude, negative half cycles. Okay, in positive half cycle, thyristor T1 is I will going to trigger, so it will going to conduct only positive half cycles. Okay, then negative half cycles, the T1 is off. Then phase with respect to neutral, T2 is conducted. So I will going to give that firing angles. It is conducting. So like about that one, so T1, T2, T1, T2, T1, T2, like it is conducting. So this is about the AC voltage controller, how it is conducting. The next one, so concept of the dual AC voltage regulator. Dual AC voltage regulator. You have looked the diagrams. So this is about the dual AC voltage regulator. What is the dual AC voltage regulator? So here is the transformer is used. What type of the transformer is used? It is a center tap transformer. Center tapping of the transformers. So the center tap of the transformer is used. There is center tap of the transformer is consists of 3 lines. Okay, 1, 2, 3 lines. Okay, I will have used it for the one single phase AC voltage controller. Another one more of the single phase AC voltage controllers. So how many number of the single phase AC voltage controllers used? 1 and 2. So dual single phase AC voltage controller is I am using. Dual single phase AC voltage controller is I am using. Okay, yeah, okay. Single phase AC voltage controller, how many switches? 2 switches. Here also 2 switches. So totally 4 switches used. So as usual, okay. So here you will going to apply the phase with respect to neutral. Okay, one half cycle, then another half cycle, neutral with respect to the phase with respect to neutral. Okay, here bottom is a phase with respect to neutral. So like it is coming. So positive half cycle. So positive half cycle is a very simple. So T3 and T1 is conducting. T3 and T1 is conducting. So this is a forward direction. Then negative half cycle, what is conducted? T4 and T2 is conducted. T4 and T2 is conducted. Okay, how it is conducted? So I will going to trigger like, okay, positive half cycle T3. Okay, after that T1 I will going to conduct it. So first T3 I will going to conduct. Okay, after that one I will going to do what I have to do. So I will going to conduct on that T1 also, so T1 also conducted due to that one. So total first initially T3 only conducted. For example, here to here is 100%, but here to here is a 50%. So 50% is a first T3 when on means 50% of the voltage is applied to the load. Then I will go to on that one T1, so 0 to 100% load is applied into that load, so that's why it is increasing the voltage. That's why the voltage is increased when I will go to on the T1. Then after that okay, it is coming to that 0. Okay, naturally it will going to turn off. Then here is a bottom space with respect to neutral. At the time what will happen, I will going to as usual, okay, but here is a flow the power, T4 is on. When is the T4 is on, okay, here is a 50% is flow to the load to close the circuits. Okay, slowly it is rising. Okay, when I will going to operate on the T2, so full, okay, inductance 100% is a flow to that load, close the circuits, close the circuit. That's all. So like about that one, it will going to operate. The waveform is, you have see that one, increase the voltage due to the dual converter, sorry, dual single phase voltage regulator. The next one is a TRIAC. What about the TRIAC? So TRIAC, if you have looked the diagram, so how the TRIAC, this is symbol of the TRIAC, how it is came. Okay, first you can look the symbol. So MT1, MT2, gate terminal. Gate is located near to the which terminal? MT1 or MT2? It is located near to that MT1, near to the MT1. Okay, how the gate is connected, how this is a TRIAC is developed? Two ACR 1, ACR 2. These two ACR is connected anti-parallelly, you can connect it. Two gate terminal is the joint. Okay, cathode, anode, these two is joined. Cathode, anode, that two is joined. So like it is developed. Okay. Then next, okay, few more points. What is a TRIAC? It is a bidirectional device. Bidirectional device means, so remaining device all are the unidirectional current control device, but it is a bidirectionally flow of the current control device. So that is a bidirectional devices. Okay, two back to back of the ACR is connected. Okay, and with one gate terminals, as you have seen about that ones. It is called as a triode. It is called as a triode. So triode. So triode, okay, it is a combined the word, okay, triode plus AC switch. So TRIAC means triode plus AC. So that's why it is called as a TRIAC. Tri means what? It is a tri means the device is it consists of 3 terminals. AC means it's a AC alternate power supply. So like it is operate on the AC power supply. So TRIAC it is developed. The next one is a 4 mode of operation of the TRIAC. It consists of the 4 modes of operations. So the construction diagram, you can draw the diagram of that ones. So here is a MT1, MT2 is opposite side, and the gate is near to that MT1s. Like you will going to draw the diagrams. So how is the power is a flow from that one MT2 to MT1. So which direction via it is a flow, that is about that divided on the this 4 mode of the this 4 mode of the operation. You can look these diagrams, then you will going to easy to understand. Mode 1 condition, the power is a flow from that C P1 N1 P2 to MT1. This is a side, it is a flow. I will going to detailly explain on that next of the video, but you will going to just look in that one introductions, then you will going to understand. See that a blue line how it is drawn, see the blue line how it is drawn, see the blue line how it is drawn. So here is a drawn that ones. Okay, it is actually it's a move from top to bottom. So here is a bottom to top, here is a bottom to top. So how it is move, so here is reached, so from here it is a move on that ones. So like about that one, the 4 modes of that operations, it's a divided. The next one, when you are going to look about that characteristics, VI characteristics of the diagram, it is similar to that one is SCR characteristics, but here is one more is what about that one, in negative side also the same look about that forward motoring. So in reverse also similar to that quadrant number 1. The next one, the last topic in the unit is called a DIAC. DIAC is a bidirectional thyristor diode. It's a bidirectional thyristor diode. Why it is coming thyristor? It is coming under the thyristor family, bidirectional thyristor diode. It's a 2 diode is connected anti-parallel, you can connect it. Okay, no gate terminal, so that's why it is called a diode. Okay, DIAC. DIAC is a develop. The term of the DIAC is obtained from the capital letter of the diode that can work on the AC. So that one is you will going to operate on the AC. So that's why it's a DIAC. It's a came on that one. DIAC is sometimes called as a gateless TRIAC. So if have the no gate on that TRIAC means that is called a DIAC. So that's all about that one. So single phase AC voltage controller, okay, and then TRIAC and DIAC. Thank you.